Hello, I'm going to outline the important ideas from 3.3, which is all about simple random samples. I hope by now that this is just a review for you after what we discussed in class. So how do we get a simple random sample? There's a couple ways. So the first way is that we can actually go through and list out every individual in our population. So obviously this isn't very realistic for large populations, but if I was only taking a survey of all the math teachers, I could do that. And we would write their names on slips of paper. The important part here is that all these slips of paper need to be identical. If half of them are bigger than the other half, that's not making it random. There's some variability in what's happening. So they need to be the same size. We would literally put them in a bowl, put them in a hat, mix them up, and draw pieces of paper we draw how many papers we want, depending on how big we want our sample to be. So that's kind of a basic idea of what a simple random sample is. Now, generally, we're not going to have a population that it's realistic to write every individual down on paper. So the other way that we do this is we assign values to our population. So much like we did with the Gettysburg Address, we numbered it from 1, starting at that first word, all the way down to the last word. There were 268 of them. So we did that, numbering them off 1 to our maximum, so how big our population is. You can start with 0, but I think it's pretty intuitive that we are using natural numbers, so we start with 1. So if you want to do 0, make sure you don't confuse yourself. I'm just showing that it is an option, but generally speaking, the practice is we start with 1 and we go to the maximum. So then we use a random number generator, which we found out that our calculator's not so random because we all got the same quote-unquote random numbers. So we'll probably look at using an applet and see if we can get some better randomization there. So we'll use this random number generator to give us however many values we want, so depending how big our sample was. If we get a same value twice, we ignore that repeat value because we don't want to sample the same individual twice. And I think that's pretty intuitive. So this is an overview of how we would take a simple random sample. So they get more complicated. There's a lot of layers to sampling, but in a gist, that's what simple random sample looks like. Everyone has an equal chance of being selected. I would write that down. Okay, now what about these samples? So no matter what, when we take a sample, there's going to be some variability there, right? So even in our class with the Gettysburg Address, we had some pretty large variability in our sample. So if we took another sample, we would get some different variability. And that's okay that it happens. There's no way to avoid it. No matter what, our sample is going to have some variability because there's no way that I can get the exact same sample twice if I'm genuinely doing it randomly. So we're always going to get some that are a little too high, a little too low. The idea is we want to have a minimization of the variability. We want to control it as much as we can within reason. So the easiest way to counteract this is we increase our sample size. So the bigger the sample we take, the more we will decrease our variability. Now there's limitations here. You might write down some thoughts, but this is 3.3, just a quick overview.